Awesome. As Mary mentioned, my name is Helen Carr, and I'm with the Department of Environmental Conservation in the Clean Water Initiative program. And I'm excited today to talk to you about the Vermont Clean Water Initiative 2021 Performance Report and how Vermont's clean water investments are paying off. So very briefly, what we're going to talk about today is I'll provide a little bit of background on Vermont's water quality, talk about the purpose and scope of the report. I'll dive into some data on investments and results, and then talk about progress being made by each geographical region in the state. And then we can jump into a quick tour of the Clean Water Interactive Dashboard online tool. So to start with a little bit of background, Vermont's lakes, rivers, and wetlands are very important environmental and economic resources for residents and Vermonters alike. They support wildlife habitat, they provide safe drinking water, recreational opportunities. They can also support local economies by fostering tourism and influencing property values. They're really part of what makes Vermont so appealing, in my opinion. So while we know that most waters in Vermont are of high quality, there are several that suffer from excess pollution, such as sediment and nutrients coming off of the landscape. So for example, excess phosphorus in our lakes can cause an imbalance, which can lead to unsightly and potentially harmful cyanobacteria blooms, or these algae blooms, and these can be harmful to health as well as have an impact on our economy. So in order to mitigate these issues, clean water restoration plans have been established. And we refer to these restoration plans as total maximum daily loads, or TMDLs, because they identify the maximum amount of a pollutant that a water can receive and still meet water quality standards. So if we look at the map in the middle of the page here, we can see that throughout the state, we have several large-scale TMDLs. The area in green drains to Lake Champlain, where the pollutant of concern is phosphorus. And similarly, in light green, we can see Lake Memphremagog is also impaired for phosphorus and has a TMDL there. And in the eastern half of the state in blue, that drains to the Connecticut River and then eventually to the Long Island Sound. The pollutant of concern in Long Island Sound is nitrogen, and nitrogen can also cause imbalance in the ecosystem, leading to low dissolved oxygen, which can be harmful to aquatic life. But the state is committed to addressing these issues. In order to work towards achieving these TMDL goals, the state is investing in clean water projects that aim to reduce nutrient and sediment pollution across different land use sectors. So for example, in the agricultural sectors, projects address runoff and soil erosion from farm production areas and farm fields. In the natural resource sector, these projects restore the functions of natural infrastructure. So that means river channels, floodplains, lake shores, and wetlands. In the stormwater sector, stormwater treatment practices are implemented to address runoff from developed land, such as parking lots, sidewalks, and rooftops. And then similarly in the road sector, projects address stormwater runoff from roads, from both paved and unpaved roads, and they can help prevent erosion in both in the ditch and on the road itself. In the wastewater sector, we have practices that help or projects that help decrease nutrients such as phosphorus and nitrogen through enhanced wastewater treatment systems, and they help to address aging infrastructure by upgrading facilities or optimizing treatments. I also want to highlight that there are a variety of co-benefits to these clean water projects. So in addition to addressing water quality, these projects can also help to improve fish and wildlife habitat. They can protect against flooding. They can help mitigate climate change effects. They can provide a more resilient infrastructure. They help to support workforce development through the influx of funding for these projects, and they can also enhance recreation. So a variety of benefits all across the board. So the performance report is really a tool that provides us with accountability and transparency to the public, the legislature, and the EPA, the Environmental Protection Agency. So we have put this report out for the past 6 years, and we've used these same water quality accountability measures to show our progress that's being made. So an investment measure in the report is showing how state of Vermont invests in clean water projects from planning to design and implementation. Education measures are showing really demonstrating the public awareness and engagement in implementing our clean water priorities. Our project output measures are helping us to quantify the results of state-funded clean water projects. And lastly, our pollutant reduction measures are helping us to quantify the estimated nutrient load reductions achieved by clean water projects. So we will hear more about these a little bit later, but to give you an overview, these are kind of the measures that we're using within the report. Okay, so what is the purpose of the report? Really, the purpose is to summarize Vermont's clean water efforts and to demonstrate how investments, educational programs, and regulatory programs are making a difference. The data within the report covers state fiscal year 2016 through state fiscal year 2021. And our state fiscal year is run from July 1st through June 30th of each year. So the report is divided into chapters based on geographic region. As you can see on the map in the middle here, the chapter 2 is focused on all statewide results. Chapter 3 focuses on Lake Champlain, Chapter 4 on Medford-Magog, and Chapter 5 on Connecticut River. And I'll go into each of these in a little bit more detail. Kind of another purpose of the report is to demonstrate how our combination of state funding programs, federal funding programs, regulatory programs are contributing to progress towards achieving Lake Champlain and Lake Medford-Magog TMDL. Okay, so let me dive into our state clean water investments. So first, the kind of definition we use for state clean water investments are dollars that were obligated, awarded, or loaned to clean water projects by state of Vermont agencies. So in this figure on the slide, we are showing that that state of Vermont agencies have invested a total of $257 million in clean water projects from 2016 to 2021 through grants, loans, and contracts. Of the 257 million, about 168 million were awarded through grants and contracts, and about 89 million were awarded through low interest loans through this Clean Water State Revolving Fund. So when we look at this figure, we can see that over time, annual clean water investments have increased more than fourfold statewide since 2016. But we can see there is variability in funding awarded to projects due to project readiness and some other factors as well. We can also see that investments are well distributed across all land use sectors because action is needed across all sectors to meet our goals. We do see a little dip in 2021, and that is likely due to the COVID-19 pandemic's economic impacts. They affected the Clean Water Fund revenue sources and led to a slight reduction in appropriation and a temporary slowdown in funding programs. So that's what we're seeing there. Also want to point out that state investments can leverage other funds and contributions from local and in-kind and federal match. So we've reported about $88 million in local and federal contributions that have been leveraged from these state funds. And lastly, I'll just point out that about 83% of investments are used for project implementation, while the other about 20% have been used for project identification, project design, education, and outreach efforts. So moving on to project outputs. So this is kind of a high-level summary of results of state-funded clean water projects from 2016 to 2021 by land use sector. A couple of highlights when we look at the agricultural sector, over 155,000 acres of agricultural conservation practices have been implemented on fields and pastures. In the natural resource sector, over 360 riparian acres, or the areas adjacent to rivers, lakes, and wetlands, have been actively restored through buffer plantings and floodplain restorations and lakeshore restorations. In the developed land sector, we've reported that 260 municipal road miles have been improved through drainage and erosion control practices, and over 440 acres of existing impervious or hard surfaces have been treated by stormwater treatment practices. In the wastewater sector, we are showing 6 wastewater treatment facility upgrades have been completed. So we really kind of encourage you to review the report and to dive a little bit more deeply into each of these sectors if you're interested. Excuse me. Now I want to transition to discussing the progress that's being made by geographic region. As I mentioned earlier, Lake Champlain and Lake Vermont have these phosphorus TMDLs, which provide us with a target reduction that we're required to meet by a certain date. We work to track and account phosphorus reductions achieved through clean water progress to show how much progress is being made. We can only account for phosphorus reductions at this point. We do not yet have a method to account for nitrogen reductions being made in the Connecticut River Basin, but we are continuing to track all clean water project data and measures in that region. Okay, to start with the Lake Champlain TMDL. To give a little bit of background on the Lake Champlain TMDL. So this report is also provided to the Environmental Protection Agency as a tool to hold us accountable. Our TMDLs provide reasonable assurances that reductions can be achieved. And so far, the EPA has given us a satisfactory rating on the Lake Champlain TMDL progress. So to go into a little bit of how they assess our progress, they assess progress based on a rotating basis, basin by basin. So each subbasin within the Lake Champlain develops a tactical basin plan. Those plans outline implementation efforts and targets. They're on a 5-year planning cycle. So the plans include implementation tables that identify and prioritize specific strategies and practices to be implemented by identified dates. And about halfway through the reporting cycle, an interim report is submitted to EPA. And then after 5 years, at the end of the cycle, a final report is submitted to EPA. So if you're looking at the report, we have 3 appendices in the back, and they correspond with the reports that are provided to EPA. So those reports were written by our wonderful basin planners, Karen Bates and Danielle Awarski. So we have the Missisquoi Bay final final report, the Lamoille final report, and the Wisniewski interim report at the end of the at the end of the report if you are interested in learning more. Okay, so this slide is showing our estimated total phosphorus load reductions in metric tons per year. So if we're looking at this chart, well, first of all, a metric ton is about 2,200 pounds. Our reductions are reported through state and federal funding programs, as well as regulatory programs in Lake Champlain. If we look at state fiscal year 2021, we have an estimated 34.8 metric tons, or about 77,000 pounds of total phosphorus loading have been reduced as of 2021. And each of the different colors in the chart represent the different land use sectors. So we can clearly see that most of the reductions have been achieved in the agricultural land use sector. And there's a couple reasons for this. And one being a high volume of the funding from federal funding programs, specifically from USDA and RCS, are allocated to projects in Lake Champlain. Second, agricultural practices are highly cost effective. So the amount of money spent results in a high level of reductions. And third, methods are in place to estimate phosphorus reductions from almost all types of agricultural practices, while there are other land use sectors that have gaps in methods to estimate phosphorus reductions. So we hope to see those other sectors increase in the years to come. Overall, we see a steady progress being made year over year within the Lake Champlain Basin. So shifting over to Lake Memphremagog phosphorus reductions, this is a similar graph as we saw in the previous slide, showing estimated total phosphorus load reductions in metric tons per year. As we can see, by state fiscal year 2021, we have reduced an estimated 1.8 metric tons, or about 4,000 pounds of total phosphorus loading into Lake Memphremagog. Similarly to the previous slide, most of the reductions are coming from the agricultural sector. We do see a bit of a leveling off in 2021, and this kind of temporary slowdown in practices happened in 2020 and was due in part to conservation practice implementation by farmers during COVID-19. Was slowed down due to the pandemic. So phosphorus reductions from practices installed in 2020 carry over into 2021 based on the lifespan of the project. So it's important to note that the project lifespans are important in this chart, as an annual practice in an agricultural sector will need to be implemented year after year, as compared to a structural practices such as a stormwater treatment practice, which can last for 10 to 20 years or more with good maintenance. Yeah, so it's important to note that reductions are the result of a cumulative effect of implemented projects based on the project lifespan. Okay, so this slide is showing reductions as discussed in the previous slides, but in the context of the TMDLs that they are a part of. So if we look at the first chart on the left, we can see the Lake Champlain TMDL progress. As we stated before, we have estimated 34.8 metric tons per year of total phosphorus load reduction has been achieved. And that equates to about 16% of the way towards our target of achieving a 212.4 metric ton reduction in total phosphorus load. And the target is set for the year 2038. So that means we're about 6 years into a 20-year target plan. And similarly in Lake Memphremagog, we see the estimated 1.8 metric ton per year total phosphorus load reduction was achieved, and that equates to about 12% of the way to the target load reduction, which is 15.2 metric tons per year by the year 2037. So I want to note that this is likely an underrepresentation of progress that we expect reductions to ramp up in the coming years. This is due to, again, our gap in our ability to quantify phosphorus reductions for all project types. We are working to address these gaps this year, and hopefully we'll see the results of gaps, or the closure of those gaps in the coming years. In addition, regulatory and funding programs are ramping up to increase the pace of phosphorus reductions. I will note that these are, again, are estimated based on implemented projects. They show our level of effort, but they are not necessarily reflective of conditions in the lake itself. Lake Champlain and Lake Memphremagog are large, complex ecosystems, and the results of these efforts may take a long time to see in the lake. This is partially due to external factors beyond our control, such as climate change and land use change. We know it will take some time for the lake to respond, but we continue to track estimates to show incremental measures of progress towards meeting phosphorus reduction targets. And I just want to point out a couple things in the Connecticut River Basin. As I mentioned, we do not yet have a way to estimate nitrogen reductions in the Connecticut River Basin. However, EPA-supported efforts are underway to develop consistent methods for all 5 states in the Long Island Sound. And yes, in order to estimate nitrogen reductions for clean water projects. But what we can say is that the state has invested $67 million in the Connecticut River Basin. We have reported over 10,000 acres of agricultural conservation practices implemented in this region. We reported nearly 400 acres of riparian corridors have been conserved through easements, and over 100 miles of municipal roads have been improved, and erosion control improvements have been made. I'm getting close to the end of my time here, but I have a couple more slides. This slide really summarizes the state's cost effectiveness of major project categories. So cost effectiveness, kind of our definition is the state cost per the kilogram of estimated total phosphorus load reduced over the project lifespan. So in other words, it represents the cost to reduce 1 kilogram of total phosphorus. The estimates are based on the anticipated project lifespan. So if a project exceeds the anticipated lifespan, cost effectiveness would improve. Looking at the figure here, we are using a violin plot to illustrate the cost effectiveness of agricultural field practices, buffer restoration practices, road erosion remediation practices, and stormwater treatment practices. A violent plot combines a box plot and a density plot. The box plot basically shows the minimum, maximum, median, and mean value of cost effectiveness. Overall, we can see that agricultural field and pasture practices are the most cost effective at reducing phosphorus loading, costing an average of 194 kilograms or dollars per kilogram. And stormwater is relatively the most expensive categories displayed here, costing an average of 5,400 dollars per kilogram. We can see that also road erosion remediation projects have the greatest range in cost effectiveness, which may be the result of municipalities have been mitigating the highest priority in the most complex road segments in order to comply with the municipal road general permit, resulting in a wide variety of cost effectiveness. So I'll just note that while projects vary in cost effectiveness, clean water planning efforts really strive to target the most cost-effective project opportunities within each category. Some project categories are more cost-effective than others. We understand that, but we are required to reduce phosphorus pollution across all land use sectors, according to the TMDL, in order to meet our goals. Okay, wrapping up. So takeaway messages are this report really demonstrates the state's long-term commitment to restoring and maintaining water quality. We see results across land use sectors. We're seeing steady gains in reducing phosphorus pollution from entering Lake Champlain and Lake Vermont. These are worthwhile investments, not only because they improve water quality, they also help protect public health and safety. They help increase climate and flood resilience. They benefit the local economy, improve habitat, enhance recreation, etc., etc. But really, this report is a great tool to demonstrate our accountability to meeting these long-term goals. And I'm a little bit, I think, over time, but I wanted to say thank you so much to everyone who contributed to this report. It's a huge effort prepared by the Clean Water Initiative program on behalf of Secretary of Administration, but we've gotten so much help both from internal state agencies and agencies outside our department, including and special shout out to Tim Pricer, who has supported our data management and database development of this report over the past 6 years. Huge help, couldn't have done it without him. With that, I will transition over to a little tour of our Clean Water Interactive dashboard, and you are welcome to follow along if you would like. Let's see if I can click on this. Let me stop sharing. How are we doing on time? Okay.
I think we're doing pretty good. We have some great questions in the chat that I think would be good to get to. Maybe we can do a quick run through of some of maybe a 1 page or 2 and just show people where the Clean Water dashboard is.
Yeah, sounds good. Yeah, apologies for going over a little bit. My computer is currently freezing.
I could also share.
Yeah, I might. Are you seeing my screen right now, or?
It's just black for me, like it hasn't loaded.
Oh. Okay, maybe that's why.
Oh, there it is.
I see it now. Okay.
Yeah.
Okay. So just wanted to show how to get to our clean water dashboard. You can go through the clean water portal and you click on the first clean water interactive dashboard. It brings you to this home page of the dashboard. And we have several different pages corresponding to different output measures. And I'll point you to, we do have a help page if you're unsure how to use the dashboard, but to give an example, I'll just click quickly on the investments page. So this is a helpful interactive tool because you can click on any of the colored shapes in order to filter data by that. So if, for example, you were interested in what's going on in Chittenden County, when you hover over Chittenden County, it provides you with more information, and it also filters the data throughout each of the other visuals. And then you can choose to include or not include different funding categories. If you want to unfilter, you can click off of the colored space into the white space, and it will reset the data. One more thing is you can right click on a visual and you can click show as table, and it will give you the actual values based on what you've filtered it by. So that's a pretty cool thing if you want to pull the actual numbers out of this. So it includes various project output measures. They're filterable based on county or watershed or land use sector. And then pay attention to the funding category as well. It defaults to just state funding, but you can click all funding and that'll add in the data from all funding sources that we have.
It looks like we have a question from Dan.
Sure.
Hey there. Thanks, Scott. You got a good presentation. Appreciate it. Can you clarify just to what extent this reporting captures projects not funded with state dollars or federal dollars that you guys are administering?
Yeah. So we're not focused in the report on reporting dollars that were funded outside of the state. But in the whenever we're reporting on TMDLs, we include all the data that we have from all the different sources. So
Well, let me ask a more discrete question.
Yeah.
For municipal roads general permit projects, are you just taking all the segments that were upgraded in a given year and assigning them a standardized value? And then more specific question for Chittenden County would be, to what extent is work by MS4 permittee municipalities not they just funding it with their own dollars captured? So two-part question: MRGP, non-grant aid, non-better roads, just straight up municipal cash, and then MS4s.
Okay, so I would say when we capture funding that's not a part of our state funding, it's captured generally through state funding programs. So anything that's reported as match, like within for example, in grant and aid, that's included in like the leveraged funding. Mm-hmm. If a project is fully funded by a municipality, for example, it's likely not captured
Okay.
here.
And that's okay. I realize it's a lot to
Yeah.
handle, and the
Yeah.
amount of state projects is growing, so it's a lot to work on. And
May I ask a clarifying question, Dan? Are you asking about the dollars associated with that, or are you asking about the outcomes? Because if it's implemented through a regulatory program, we are working with those regulatory programs to capture the results of those projects, but we may not be capturing the investment associated with that regulatory.
I guess, I mean, presumably in your reporting to EPA, you're capturing what you can through the MS4 annual reports of you know, catch basins cleaned and things like that. And then, so, but yeah, and I don't know how to do it. Like, yeah, it's except to have like an asterisk or a rough estimate, and it would vary from town to town. But I'm curious on the, I'm curious on the municipal roads general permit, because yes, there's obviously a lot of towns using grants and aids and better road, but while they're doing those segments, they're also doing other segments just with their municipal funds. Not as a match, just some segment that's 10 miles away from the grant and aid funded segment. And presumably, if you just get the data updates from the portal on how many segments were upgraded, you could just standardize that. You may not know the cost, but at least you know the reduction. So, okay.
Yes. Yeah, so we actually did pull the data in the report. We put it under the regulatory project outputs, but we pulled the data right from the portal to show the, for example, number of segments that were inventoried, and yeah.
Good stuff. All right. Thanks a lot, guys. Appreciate it.
Yeah. Thanks, Dan. Any other questions in the last couple minutes?
We have a question from Allison. She asks, can you explain the difference of why basins have different TMDLs, like phosphorus versus nitrogen?
Sure. Yeah, that's a good question. So really what happens is the actual, let's see how to explain this. What we find through studying lakes is that the pollutant that is the limiting factor in production of algae blooms and other kind of harmful effects is phosphorus. So phosphorus is the pollutant that, if it is increased, we see those increases in harmful effects. When we look at, if you're looking at kind of a coastal region like the Long Island Sound, it tends to be that the pollutant that really drives those algae blooms is nitrogen instead of phosphorus. So it depends on the receiving water body. It depends on kind of what inputs from the landscape we're seeing that are making those impacts on water quality. Well, that helps. Maybe one more question?
Yeah. Let me see. Could you explain the progress in addressing gaps for the phosphorus reductions, and what methods are being developed to measure nitrogen reductions in the Connecticut River Basin?
I can try. I'm not an expert in the nitrogen reductions yet. But we in the phosphorus realm, we are still currently working to address gaps in accounting for projects such as a floodplain restoration project or kind of a stream bank restoration project, where the project is meant to bring a certain segment of a river back to a more natural or equilibrium condition. Those are have been tricky to quantify, but we are well on our way to quantifying those gaps. So that's an example of where there are still gaps and we are working to address them. And then as far as the nitrogen gaps, I suppose, I don't know if somebody else has a better answer than I do.
Sure, I can jump in, Helen.
Yeah.
I think there is a multi-state effort underway with, so the Long Island Sound receives waters that drain from Vermont, New Hampshire, Massachusetts, Connecticut, and New York. And there is a multi-state effort that's being coordinated at the regional level to establish methods for how we estimate nitrogen reductions associated with clean water projects and wanting there to be regional consistency. So we're engaging in that effort, but sort of waiting for those regionally consistent methods to become available. But the good news is, Helen had mentioned, we are tracking these projects. So once we have those methods in place, we'd be able to go back and retroactively be able to apply those estimates of nitrogen to all the great work that's been happening in the Connecticut River Basin of Vermont, which drains to Long Island Sound. So I hope that helps in terms of why that currently is a gap. And really it has to do with how we estimate the nitrogen that is delivered off the landscape and the nitrogen performance, the performance of different project types and being able to treat and reduce nitrogen through runoff events. And so we'll certainly be working on filling that gap over time.
All right, well, thanks everybody for coming. I would recommend checking out the Clean Water Interactive Dashboard if you're still curious. There's a lot of information presented there. So yeah, I hope you enjoy the rest of your afternoon. Thank you for coming.
Thanks, everyone.
Thank you, everyone.
If you have questions, feel free to reach out. I'll just drop my email in the chat if I didn't get to your question, but thanks for coming. This was great.
Thanks, Helen and Mary. Nice job.